So I just want to start by explaining how the internet works. Just an overview, not in depth. What the user does is, let's say the user, we have this website AWS training, for example. The user will enter AWS training, and that request goes to the DNS server, where the DNS server, these are servers spread out across the entire world. All these are populated, like any website will, when you create a new website, it will send a request to a DNS server saying that, hey, I am AWS training and my IP address is so and so. So the first thing that the browser does is it contacts the DNS, and the DNS, it tells the DNS, please give me the IP of this particular website. And then the DNS replies that this is the IP. The browser then sends a request to that particular IP address. So this was the IP address which was received from DNS, and uh, the browser will send a request to this IP address, which will flow through the internet and reach the servers. And the server then sends the pages related to the particular website. So this is the process how we view the website. So there are multiple steps. That first request is sent to DNS, and then the DNS sends the IP address, and then we contact the web server. We have this website. You can also visit this submarinecablemap.com, and basically this links that you are seeing, this is the internet. So we have all the continents and various countries connected through cables, submarine cables. And let's say we are here in India. So whenever we browse something, the request through from our phone, it goes to the tower. From the tower, through cables, it reaches one of these ports. There is one in Mumbai, another one in Chennai and Kochi, then Trivandrum, and this is Tuticorin. So those requests through the wireless or maybe wired network, it reaches here, and then through these cables it is routed across the world. See, for example, in Mumbai there are many cables connected here. If we click on this, it shows its total length. You can see where all it is connected. So it starts from Atlantic crossing something, I don't know where it is, somewhere in the UK. So here we can see the landing points where all it is connected, and one of them is Mumbai. So let's say you are pinging some website which is located in Italy. So the request through this cable, it will flow through this channel here, and it will reach Italy. And then from this point, it is internally distributed inside Italy, and it comes back to you. This way there is an entire network of cables which are connecting different countries together, and that is the backbone of the internet, or what we call as internet. So internet is nothing, just many computers, many computing devices connected together and sharing data with each other. Now where does cloud come into picture in this? So cloud is, let's say you are creating a website, and that particular web server for that website is located in Mumbai. Now you want all the users across the world to view your website, so all the requests can come here. But from a user point of view, the user is not bothered where exactly the server is. The user is only bothered with getting the service. So this concept of cloud, it has been there for a long time, and recently in the past 2 decades or so, it has become more and more popular. So cloud computing is, from a user point of view, the user does not need to know where the servers are located. So it can be anywhere in the world. The user is just concerned with the service. Cloud are nothing but computing resources, computing and storage resources, which are stored multiple places in the world. We are using those services for our business or for our needs. Coming to AWS, AWS is also one such cloud provider. It is called the pioneer of cloud computing. The word cloud, it's like a cloud can be anywhere. This particular resource of computing or storage can be anywhere in the world for a user. For example, most of us would be using Google Drive. Google Drive is a example of cloud storage. So we don't know where it is stored, we don't know where the servers are, or the storage is. It's just we are using it. It's somewhere we don't know. Now, what are the benefits? Why more and more businesses are moving towards cloud? Because cloud provides some very unique benefits which the previous models did not provide. The earlier models were that we will have one, we'll have our own dedicated servers, we'll have our own dedicated computing for all the services that we provide, and as and when the need arises, we will increase or decrease our computing resources. So the model was something like, there is one company and this has, you might have seen somewhere they have this server rooms where there are multiple racks of servers kept, where through which they are providing their services. Now say you are starting your business, let's say something like Zomato delivery, and you are estimating that per week you will get 10,000 orders, or you are estimating that you need a server that can serve 10,000 concurrent connections. So what happens, this is an estimate, good guess, very educated guess that you have taken, and you are buying servers and storage capacity that can support 10,000 users. Let's take for example, this costs you 50 lakh rupees. Now what is the problem with this? The problem with this is, first of all, there is a huge capital expense that you need to put in, and the second problem is, you have estimated 10,000 concurrent connections, but what if you have only 5,000 connections? That means the capacity, the extra 5,000 capacity that you have, this is going waste, right? Or on the other hand, if your business does very good, you estimated 10,000 but you are getting 15,000 requests, connection requests. In that time, this extra 5,000 that you have, this is a loss. So this is one use case that cloud solves, that you don't have to estimate, have exact estimate. So in one case you are wasting your resources and the investment, in other case you are running a loss. So cloud computing gives you resources on demand, that as and when the demand increases, you increase your resources. If the demand decreases, you decrease your resources. So if you go with cloud computing, you can do something called auto scaling. So you are saying that begin with resources for 5,000 connections, and if there is extra load, keep on adding more servers. So as the demand keeps on increasing, your resources will keep on going high. And you are also saying that if there is no demand, keep on decreasing these resources. So you are only paying for how much resources are required. You are not paying for what is not going to be used for you, or you are also not running the situation where you need to serve customers but your resources don't allow you to. And they all the clouds, they have this model of pay as you go. Pay as you go. So this is once you create the account, at the end of the month you will get a bill that will show you how much resources you have used and how much you need to pay. So for AWS, so far in 4.5 years, it has not happened with me that they have auto debited. That option is there, but you can also pay once you get the bill through your net banking or debit card. You don't necessarily have to give credit card. Credit card thing was long back in 2009-10s that you could get it only through a credit card, but now there is a lot of flexibility. So you don't have to be afraid that if you try, you need to give credit card and money will be auto debited every time. No, that is not the case. So two of these benefits are auto scaling or resources on demand and pay as you go model. The other thing that they provide is, you don't have to bother about procuring the resources. So you don't have to bother about, let's say, buying a server or buying storage capacity and all, and you also don't have to break your head with managing those resources. So think about this: if you have servers that cost you 50 lakh rupees and they are serving 10,000 connections, how much additional cost it is going to be to maintain this? You will need air conditioning rooms, air conditioning, and you will need space. That space will require rent. Maybe it is your own property, but it could be given out to someone else or for some other use which could generate income for you. Instead of that, it is going to host this. So you need maintenance, and you also need trained people to maintain all these things. So it's not just the cost of the server, there is additional recurring cost which comes with having your own servers. So these are the unique benefits which cloud computing gives. Now think you want to launch your own business, but it requires 50,000 of minimum capital investment. So this itself can put many ideas off. Instead of that, you have cloud computing where you don't have to pay anything. You start and build as you go, keep on improving, and as your business grows, your resource consumption will grow, and since your business is growing, your revenue will grow, so you can also pay for the extra resources that you use. Okay, before that, okay, we'll go to AWS. So you can just search for AWS and you will land on this page here. So I'll walk you through a little bit of this through a website, and here what you have is products. Here you can see most of the services or products which AWS offers. As you can see, there are quite a lot of them, and it's very easy to get lost in it. So it's always better you start with some basics, and instead of jumping at very advanced level, build slowly on that knowledge. Then you have pricing, where you can see how the pricing is. You can you do a calculation of how much it is going to cost you to use something and optimize your cost. There is also this AWS free tier. So pricing is how do you pay? You pay as you go, save when you commit. So this model is let's say you have estimated 10,000 server resources, and for that you are saying that no matter what, I am going to use X amount of resources for 1 year. So you are committing that you will use X amount of resources. So in that case, you pay less. On demand is you are using the resources as and when required. That is pay as you go model, and pay less by using more. The more cloud resources you use, the lesser you have to pay. We'll see that in the pricing model. Then we have for all the services, the pricing is mentioned here. You can have a look at it on this page. Let's see about compute. So they have a service called Amazon EC2, which is Elastic Compute Cloud. They have a free tier in this. That includes 750 hours of Linux and Windows T2 micro instances. So what are instances? Instances are say for example a representation of an entire machine or a laptop or a PC. So instant types, okay, I'll show it to you here. Say for example T2, this was given in example T2 micro, that is one virtual CPU. What is one virtual CPU? It might be described somewhere. Virtual CPU, I think Intel Neon processor. The processing power provided by one Intel Neon processor, 6 CPU credits per hour. Will not get into that, it will make it little complicated for now. You have 1 GB RAM, and network performance is low to moderate. So you are getting this entire resource for free, 750 hours per month for the first 1 year. There is a free tier types of offers. 12 months free, Amazon EC2 Cloud. So 12 months free from the day you create your account. for 12 months. Every month you will get 750 hours to experiment on it. This is T2 micro or T3 micro. Let's see what T3 micro is. So you go to T3. T3 micro is 2 virtual CPUs and 1 gigabyte of memory. This is like you are taking a PC on rent. Instead of buying a PC, you rent it for some time and then you let it go that I don't need it anymore, and you don't have to pay for it. Let's look at the pricing also. Yeah, the on-demand pricing. We'll look at the on-demand pricing. Per second billing, yes, you only pay for what you use. It takes cost of unused minutes and hour. So you basically minimum 60 seconds you have to pay, and above that per second you need to pay how much you have used. T3 micro is $0.0104 per hour. This is hourly rate. Per hour, if you are using this, you need to pay this much dollars, and that too at the end of the month, not in the beginning. Similarly, there are many other resources. Let's go to some high-end resources. Let's say this T3 2x large, that is 8 CPUs, 32 GB RAM. T3 2x large is $0.03328. So how do businesses use these? Are when they have some let's say they are working on 3D designing and they want to render some graphics or something which is going to require huge computing resources, or training a ML model. In that case, you can take this kind of resource. Once the training is complete, you can terminate it. So instead of buying a laptop that will have this kind of resources, will cost you too much upfront. Instead of that, you are taking on rent, which is going to cost you only this much per hour. So this is one benefit, and this is an example of infrastructure as a service. So you are getting an infrastructure here, and it's up to you how you want to use it. Similarly, we have platform as a service. For example, database services. If we go to databases, we have various databases. Some Amazon RDS, it gives you MySQL, PostgreSQL, SQL Server, MariaDB, and you have something of their own, which is Amazon Aurora, which is relational database provided by Amazon, and you have DynamoDB, which is a NoSQL database, and these are managed databases. That means many of the services provided by such cloud providers, they are managed services where you don't have to bother about the underlying resources. They will tell you these are the resources you will get, or you can say these are this is what I want, and it will be taken care for you. You don't have to worry about the upgrades, you don't have to worry about the security fixes and all. You just use it. So this kind of database services are examples of platform as a service. They are giving a database platform for use. And then we also have software as a service. Software as a service like Google Meet. Google Meet is an example of software as a service. So these are various models. And we also have public cloud. Public cloud are clouds which are easily accessible by the public. Private is something hosted by the organization itself inside their own space. So let's say this is your office and you have created one room for yourself. So then this becomes a private cloud. Or AWS and Google, Azure, they also provide something called private cloud. Usually what happens is it's not when you take an EC2 instance, it's not a separate laptop will be procured for you, set up for you. It's a huge racks and racks of resources, and you are requesting for a resource based on the agreement or which resource you select, one tiny portion of it will be allocated to you. Similarly, to the next person another space will be allocated, and so on. You can also request for private cloud, where that particular processor or that rack will be entirely dedicated for you alone, and no one will be sharing that resource with you. So the concept of private cloud, which was earlier there, that only it will be inside the organization, that has been brought to cloud, and no one else is going to use this, only you will be using it. And then there is a hybrid model where you have something in your office, and then you take something in AWS, you share something, let's say this space you are taking, and both of them are communicating with each other. So this is a model of hybrid, where you have some resources on the cloud, some resources on your premises. Let's look quickly at the free tier. So free tier, they have various options. Free trials, where maybe for 1 month or 2 months you can try it for free. 12 months free, this resources from the initial sign up date to expiry of 12 months you can use those resources, limited resources. For example, Amazon S3. Amazon S3 is a object storage. Think of it like you are storing individual files. There you can store 5 GB for 12 months. It's 5 GB at the beginning of the month, and if you have not exceeded it, by the end of the month also it will be 5 GB. So in that way it's calculated for 12 months. These are all 12 months free. Then you have something always free, which you can check. These services are always free, like 25 GB of DynamoDB. Forever this is going to be free, NoSQL database, 25 GB of storage in DynamoDB. Or AWS Lambda, 1 million requests per month are free. AWS Lambda is a serverless service from AWS. Serverless, it's like you don't have to worry about the servers. You don't have to worry about the underlying resources. They are giving you the platform, and as and when the request comes, your code will run on it, execute, and give you the result. You don't have to worry about installing softwares, installing the program tool chain and everything. And SNS is notification service. You have CloudFront. CloudFront is their edge service. Through CloudWatch, you can keep a track on what resources are getting used, how much, and you can also set up alarms. Let's say for EC2, you are planning to use only the free tier. Amazon EC2 gives you 750 hours free usage. Now with CloudWatch, you can configure an alarm that if it reaches 700, it will send you an email, or it will send you a notification that 700 hours is done. So be careful. In that case, you can have a look and maybe stop it for time being or terminate it, so that you don't incur any bill. To create this account is also very easy. You can click on sign in and create a new account. A root user. So there is something called a root user. The root user is whose email will be provided and who is creating the account. This root user account is the most powerful and the most dangerous account. So if someone gets hold of this account for your business account, your whole business can be jeopardized because of this, because only the root user has the power to delete the account. So imagine you have a business and someone gets hold of your root account and they delete all your resources or your account. What can happen? So there's a lot of responsibility that goes into handling this particular account. And as you explore more, you will get to see different ways how you can handle it. So let's create an account. I'll give my email ID. So they've sent me a verification code. I'll just check it. I'll create a password. So once you have done that, it will ask you for more details here, and step 2, it will ask you to verify a bank account, where maybe it will debit 2 rupees from it, just to check that your account is valid. And you can just proceed with it, and your account will be created. But for now, just to show you, I will log into my account to show what it looks from the inside. Once you log in, this is the console home, and to interact with AWS, you can either do it through the console or you can do it through a command line interface also, where they have a CLI tool for Windows, Mac and Linux. You can just install it and start interacting, procuring resources, or doing changes into it. So let's say this is EC2. One way you can search for services are, you can just type here on the search bar, or you can click on services here and check for various services. And there is storage also, so maybe I will just search S3, and I have S3 here. So this is the EC2 dashboard, and if you want to launch a new instance, that is like taking resources on rent or a computing resource on rent, it's a launch instance. It's a very easy process to do it. Within few minutes you have a dedicated a resource for you running. So I'll give some name, and here you can select Amazon machine image. So AMIs are, think of them like OS, which are designed to run on EC2. So this you can select Amazon Linux or Ubuntu, Windows, whichever you want. There are many available. Many of them are from Amazon or AWS itself, and there is also a marketplace where you can create an AMI for EC2 and you can put it out for people to use. And similarly, many other people have put, or many businesses have put their AMIs. So let's select Ubuntu for now, and you can select the architecture x86 or ARM. And again, whichever resources you are taking, be sure that you check on the pricing page how much it is going to cost you. So for Linux and x86 architecture, the cost will be little different from ARM architecture. And then the instance type. So here you can select what kind of instance you want to use. All the instances will be mentioned here. Say CD5.24x large. This is 96 CPUs, 192 gigabytes of RAM. And for Linux, the pricing is 4.752 USD per hour. For Windows, it is 9.168 USD per hour. So you can be sure to check the pricing before you use it. So this way you can just configure everything, security details and all. Security groups are like, what kind of requests will you allow to come into the instance? Will you allow everything, or will you allow requests from any particular IP on a particular port? Those kind of configurations you can do here. And storage configuration, how much storage you want. So here it's mentioned that free tier eligible customers can get up to 30 gigabytes of EBS general purpose SSD or magnetic storage. So these storages are meant to be used with EC2 instances, because you will have to store all the files. The AMI has to get installed somewhere, so you can attach them here. And after everything is done, you can just click on launch instance, and here on the main page, here it will show you the instance running. The instance gets loaded, and you get key pairs and all, through which you can connect to that instance. So anyone who has that key pair can connect to your instance. So you have to keep that key pair safe, because if you lose the key pair, you will not be able to access it, and anyone else gets the key pair, they will be able to access it. So this is for EC2. Then we have something, they have something called load balancers here. Think of it this way, that you have one server you have taken, and that is handling 3000 requests. So what if you start getting more than 3000 requests? You will want to add another resource or another server. Now this is also capable of handling up to 3000 requests. But when the user comes, or the DNS that we discussed, DNS, let's say your website is xyz.com. So if someone is opening xyz.com, the IP for this server will be different, the IP for this server will be different. Now for DNS, if we give two different IPs, it will get confused. It might get confused. So what we do is, we do something, use something called load balancer in between. Now this load balancer has some particular IP, and you tell the DNS that for xyz.com, this is the IP address that is to be used. So any user who wants to view the website will ping this particular load balancer, and internally the load balancer will distribute traffic to either this or this based on the load of the server. So it could be that the first user is directed to this server, the second user is directed to this server, in that way. And auto scaling also. So in this entire configuration, what you can do, if you have auto scaling enabled, as the number of users increase, you can have a configuration that if the load is more than 80% for more than 5 minutes, this is just an example. If this is the case, then add one more server. So the system will automatically add another server. Or you can say if the load is less than 20% for more than 5 minutes, you remove one server. So if you remove server, you are not incurring cost for that. Now 3000 requests for this are full, 3000 requests for this are full. So the system itself will add another server, identical server, and the load balancer will start pointing to this as well. So if any user comes, they will not be denied the service. In that way, you can make sure that all your users are getting served. This falls under availability. So with this, we are ensuring that our service is available. Okay, one thing I missed telling you is how AWS servers are organized. Yeah, the green ones that you see, these are regions. So you have in Sao Paulo, you have in Mumbai and Sydney. So these are various regions. The idea of regions is they are geographically separated. So if there is a natural calamity in let's say in South America or this particular region, it's very unlikely that the same calamity will happen here or here. So when you are designing applications, you can design it in a way to have them replicated across different regions for ensuring that reliability and availability and security of your data and all. So inside each region, there are multiple availability zones. Availability zones are like individual data centers which are separated with some distance between them, but again it's possible that they might face the same calamities, for example earthquake or something. One difference with the availability zone is that all the availability zones, they are powered by different power suppliers and different internet providers, so that even if one provider has a problem, it will not affect all the data centers in that particular region. And if we see here, so you see these are various regions which we have. Once you log in, you will be able to see this, and you can select on which region you want to use. For S3 we can't select that, but for EC2, I mean right now Mumbai is selected. I can also select Hong Kong. So the instance that I launch will get selected in the Hong Kong region. So that particular instance will get launched here, and it says here there are 3 availability zones. So it's like there are 3 data centers. For example, this is one region. Inside that there is one AZ here, one AZ here, one AZ here. So you have some services which says multiple availability zone replication. So whatever data you put in there, it will get replicated across multiple availability zones, so that even if this one availability zone has a problem, your data is still recoverable from the other availability zones. So that is how you are protecting your data or whatever service you are providing. And S3, yeah, this is what S3 looks like. You have something called buckets here. Buckets, think of them like the top level folder. Inside buckets you will be putting objects. So again, you can control the access to it. Do you want to allow public access? By default, there is everything has only private access, nothing has public access. You have to explicitly allow public access, only then it will be public. And they have something called shared responsibility model. Shared responsibility model is you and the cloud provider, you are both responsible for the security of the entire thing. So AWS is responsible for security of the cloud. We are responsible for the security in the cloud. For example, this EC2 instance which we are creating, AWS is responsible for the security of this particular infrastructure where this instance is running. but we are responsible for whatever is going inside this particular instance. AWS will not protect our data or resources whatever are running in our instances. That is our responsibility. But AWS will take care of the infrastructure, of the security of the premises, of the power of the internet, and protecting from unauthorized access and everything. These are just some overview of it, and if you want to explore more, there are some resources. aws.training, this is the website by AWS itself, where you can join many courses. For absolute beginners, I would suggest you go for AWS Cloud Practitioner Essentials. These are very basic and at a very overview level. Without going too much in depth, they will explain you various concepts of cloud and the major AWS services, and then as you get more experience, you can dive more into it. And that's what I have for an overview of AWS. Thank you so much, and see you soon in the next video.